Welcome to the Aalo Factory Grand Unveiling event.
They say everything is bigger in Texas. This state is defined by size, scale, and ambition, and that has served it well. But bigger isn't always better. In business and technology, faster is often better. Speed creates competitive advantages. It allows companies to outmaneuver incumbents, capture market share, adapt continuously, and set the standard before others even react. Look at Tesla, SpaceX, Amazon. They didn't just compete with legacy giants. They leapfrogged them. They seized the moment, moved with precision, and changed the game. But they weren't the first to do it. The foundations of modern mass manufacturing and business agility were laid decades earlier. Henry Ford's moving assembly line cut automobile production time from 12 hours to a little over an hour. Henry Kaiser revolutionized shipbuilding during World War II, reducing the time to build a ship from 8 months to just 4 days. They figured it out with invention, innovation, and perseverance. They made things faster, more efficient, cheaper, better, because they knew that when speed meets precision, history is made. At Aalo, we embrace this mindset. We believe speed unlocks value. Faster companies win by moving aggressively when opportunity strikes, iterating quickly and learning from mistakes, scaling before competitors even understand that a shift has occurred. Here in Austin, deep in the heart of Texas, we're proving that some very big things can be faster too. Welcome to Aalo. The future of advanced nuclear is here.
Ladies and gentlemen, Aalo co-founder and CEO, Matt Loszak.
All right. Hello, everybody. Thank you so much for coming here today. We are incredibly excited to show you all the things that we've been working on for the past 6 months and even before that. So today in the audience, we have an amazing turnout of investors, partners, suppliers, press, government folks, and other types of partners, and family and friends. We have a really good show planned for you tonight. We've got a couple presentations and exciting announcements. We've got a couple remarks from external parties, some folks from government, some potential partners, and different folks we can work with to deploy this technology very widely. And we'll hear a bit more from the team as well. So for now, sit back and enjoy. And to kick things off, we'd like to invite Adriana Cruz to the stage. So Adriana is the Executive Director of the Texas Economic Development and Tourism Office. And she works directly with Governor Greg Abbott. And so without further ado, Adriana, over to you.
Thank you. Thank you so much, Matt. And good evening, everybody. It's an exciting night. So happy to be here for the grand unveiling. And this is quite the curtain that we're gonna see what is behind. But as Matt said, my name is Adriana Cruz, and I'm the Executive Director of the Texas Economic Development and Tourism Office in the Office of Governor Abbott. And you know, we saw in the video, Texas is big. Texas is known for big ideas. Texas is fast, and that is also important. But the future is building here in Texas. And here in Austin, Texas, at the new Aalo-X facility, 400,000 square foot facility. Very excited to be here with you tonight for this grand opening and grand unveiling. You know, Texas is the energy capital of the world. And that is something incredibly important. And Aalo's new facility is going to help us with the all of the above and all of the below strategy that we have in Texas, our energy evolution strategy. And so we're very excited about this opportunity, what this means for the state of Texas. But really, better than me telling you, it's my honor to introduce a video. We're going to hear a video message from the governor of the great state of Texas, Greg Abbott.
Hi, this is Governor Greg Abbott. I'm honored to welcome you all to Aalo-Atomic's factory grand opening. Texas is thrilled to be the home to one of the fastest growing nuclear companies in the entire nation. Our state is growing with a booming economy, a massive influx of people, new data centers, and so much more. All of these developments require more power generation. That's why I announced the launch of a nuclear renaissance in Texas. Aalo's pioneering reactors and huge investment in Texas will keep us leading the nation in energy production, as well as create good paying jobs for our fellow Texans. I look forward to seeing what Aalo produces in the many years to come. May God bless you in your endeavors, and may God forever bless the great state of Texas.
Ladies and gentlemen, please welcome to the stage Reed Clay, President of the Texas Nuclear Alliance.
Good evening. Never fun to follow the governor, but I worked for him for close to 10 years, and it's an honor to stand next to him and Adriana virtually. Well, Adriana's here, but virtually the governor. Wanted to take a moment to recognize that it's his leadership is the reason that things like Aalo are possible in the state of Texas. He likes to say Texas moves at the speed of business, and you heard Aalo says that they want to move faster and faster and faster, and that is why Texas is the perfect place for this. I also want to take a moment to recognize the governor, his leadership in making nuclear a priority this legislative session. He announced at his State of the State address that he wanted Texas to lead the Texas nuclear renaissance. That at the Texas Nuclear Alliance is our mission. We want Texas to be the Texas nuclear capital of the world. It is the energy capital of the world, but for the last 30 years, nuclear has been very noticeably absent from that equation. And we formed the alliance 3 years ago to ensure that that would change. It's really a great honor. When we started the alliance, this is part of what we envisioned. Of course, we wanted to deploy nuclear and make the Texas grid the most reliable and the cleanest in the nation. But we also knew that the nuclear renaissance was going to require more manufacturing, more jobs, more investment. And Aalo's done that here in Austin and in the state of Texas. So tonight, for me, it's a real honor to help to see this vision start to really materialize with Aalo's leadership. And I'm humbled and honored and grateful to be here alongside visionaries and builders, importantly builders like Matt and Yasir. And I'm honored to welcome them to the stage tonight. Thank you.
All right, so thank you, Reed. So my name is Matt Loszak. I'm the co-founder and CEO of Aalo-Atomics. And I wanted to start with a little bit of a personal story. So I grew up in Toronto, in Ontario, Canada. And during my early years, I had asthma, breathing attacks, which were pretty scary and uncomfortable. And this was because we actually had 62 smog days per year, largely because of the coal plants that we had in the area. But fortunately, the government decided to turn off those coal plants, and we went all in on nuclear. And the number of smog days per year went from 62 to 0, and my breathing problems went away. So that was my introduction to nuclear, and I thought, wow, this is incredible. And I think this story goes to show just how important this technology is. So our belief at Aalo is that we should be deploying as much nuclear as possible, as fast as possible. And the question is, why are we not building more of it? A lot of people think that the NRC is to blame. They think the regulator is some kind of bogey man who's just holding the system back. But this is not really the case. In fact, there's actually 8 utilities that already have approved licenses to build large nuclear power plants, and they're choosing not to. The reason they're choosing not to is because of a fear of cost and schedule overruns. So Vogtle is the most recent example, 7 years late, 17 billion over cost. This is why we're not building more nuclear. It's not predictable. So what is the solution? One example that we find really compelling is someone who should probably be more well known. His name is Henry Kaiser. So he was around the same era as Henry Ford. And instead of working on cars, although he did actually work on cars for a bit, but he worked on boats primarily. He also did roads, tunnels, the Hoover Dam. But during World War II, he and his team built 1,400 ships. It was around a third of the fleet. And at the time, building these large ships took 8 months before their team came in. But their team brought it down to 4 days. So this shows what's possible. And so how did they do this? Well, they took a factory mass manufacturing approach where they had several factories working in parallel and making mass manufactured modular units and shipped them all to a centralized site for construction. So it might sound obvious, but it's incredibly impressive to see what can happen when this is done right. And so Aalo will make mass manufactured nuclear power plants a reality. That is what we are doing. And we're doing it very fast. So this is the busiest slide, I promise. You don't have to read all the text. But it kind of shows just how fast we're going. So as a company, we're actually just around 2 years old. In the first year, we did a 6 million seed. In the second year, we did a 30 million Series A. And this is now year 3, and we're aiming to do 100 million Series B. And that Series B is going to pay for the first real power plant that we built, which is incredible. If you kind of look at it, to go from 3 years from a corporation to constructing a real power plant, that's somewhat unprecedented. So we're very proud of this speed, and we intend to keep this up, if not accelerate. So here's a photo of the team 1 year ago today, basically today. So on the left, you have the Austin team. There was 3 people and myself. And on the right, you have the Idaho team. And we were working out of a WeWork, and we had a lot of big ideas. 6 months ago, we'd scaled the team to around 20 people. And we moved into this factory space, this 40,000 square foot shell. And today, we've doubled that team to 45. And this photo was taken literally today. And we've done a lot that we are very excited to show you guys. So if this factory vision for nuclear is kind of obviously a good idea, why has it not been done before? So the thing is, all the nuclear plants today that have been built in the US and basically the world are bespoke. They're one-off for the most part, maybe twosies or threesies. But there's never really been the right type of demand to justify a reactor or nuclear plant factory. Mostly these were government one-off projects. So we believe that the AI data center movement will be the big unlock for the nuclear plant factory vision. So why AI data centers? Well, there's 2 main reasons. One is it's the fastest growing. So it's growing very fast, and you can see here some of the projections, but it could be on the order of tens of gigawatts in the next couple decades, which is incredible. I mean, 1 gigawatt is 1 million homes. That's like a city. So we're talking about building several new cities worth of electricity generation in the next couple decades. And so we view this as the ideal recipe to bridge the gap between folk to noke, because the second main reason that AI data centers are a great initial target is they have a higher willingness to pay, because they need clean, firm baseload fast, which is valuable to them. And so the last thing I'll say here that's kind of exciting is data centers, while growing rapidly and well suited, it's only currently 1% of power generation in the country. So once we bootstrap this factory for that initial market, we can then go after so much more and help provide cheap, clean baseload energy to a whole swath of other incredible areas. And one day, our goal is to take that model to other countries and help bring a lot of people around the world out of energy poverty with electricity generation that doesn't harm their health. So we asked ourselves, what is the optimal product to power the growth of AI? What is that product? Is it the reactor? Well, no. The reactor is just a component in the system. The overall system is the product, and that is the plant. And that product has to solve a customer need. It can't just be technology for the sake of technology. It has to be designed with a lot of customer discovery and conversation and so on. And so today, we are introducing a revolutionary new product. And I'm excited to show it to you all now. Introducing the Aalo Pod. So here is what Aalo's initial product will look like. This is a factory mass manufactured 50 megawatt electric, 50, nuclear power plant, which has been purpose built for AI data centers. So one of the key properties of this product is that there are 5 reactors and 1 turbine sized for those 5 reactors. So why is 5 reactors important? What that means is when any one reactor is down for refueling or maintenance, the others can make up the delta. So you can have power all the time, which is very important for these data centers. What that allows you to do is save time and money. It saves time in the sense that interconnection queues take a long time. And if you can install this quickly, you can then get power faster and optionally tie into the grid. And we're seeing here that sometimes interconnection queues can be up to 5 years, which is crazy. And it can save money because often transmission and distribution is half the cost of delivered electricity. So this is a pretty fascinating chart. In the past 10 or 15 years, the total height of those bars has stayed the same. So power prices are somewhat constant. And the electricity generators have been doing a good job, the green, of lowering their costs. But that's been offset by a grid that is aging and requires more and more capital expenditure to bolster. And so by bypassing the grid as an option, you can save money significantly, seeing how much T&D actually costs. Said differently, there's a lot of value to on-site power that's available all the time. So this is what this would look like when paired with a data center. So you can see here, there's a few pretty interesting characteristics of this product. It has a very small footprint, so it uses around 20 or 30% of the land of an equivalent load from a data center. It has a very tight EPZ, emergency planning zone, and so this means that essentially the fence boundary is where you have to worry about from a regulatory perspective. And relevant to Texas, it has essentially no water required on an ongoing basis. So this means you can use this at any longitude or latitude, and even use it to manufacture water with desalination. It's another story. And then, as you can see here, each of those pods is 50 megawatts. So it scales quite nicely for hundreds of megawatts or even gigawatts. And by the way, in this factory, I know you can't see the whole thing, but you could fit 2 Aalo Pod buildings in this factory space. So keep that in mind. Okay, so why did we go with this design? One thing we wanted to make sure of is that we didn't want to do an opera house. You know, something where you see it and you think, holy crap, that looks expensive. Similarly, we didn't want to do something that looks scary or unappealing. You know, there's somewhat negative connotations with some types of architecture in nuclear, and we didn't want that. So we wanted something where people would say, not NIMBYism, not in my backyard, but YIMBY, yes in my backyard, where they'd want it. And one of the criteria we gave our architects is we wanted our mothers to see this and say, oh, that looks nice, that looks welcoming. So for scale, there's my mother in the bottom left corner there. So it's kind of more of the size of a barn. It's not really a house kind of thing. And the architecture firm that we did this with is Hariri Pontarini Architects. And the designs are understated, warm, and welcoming. So it's a very mass manufacturable design, and we'll get into that. And it's somewhat iconic in the sense that you can imagine really recognizing this when you see it deployed around the country and the world. Okay, so here's how this would get constructed. Essentially, it's a lot of modular units made in the factory. The foundation is shipped on site, placed into a hole. So this is below grade. Then comes the reactor and the secondary system. You chip in the walls in a modular way, the glazing, the nuclear spine, we'll talk more about that, and the roof. And that is one section of a pod. So here's a video to show how this might look. So to kind of dive deeper into what the inside of this thing is, so along the middle, you have the nuclear spine, and that's essentially a concrete, very rectangular section that allows for the 5 reactors to be placed all in a line and have shared equipment for refueling and maintenance and so on. And this is a key part of the economics, because if you have one reactor and one turbine and one set of staff and one set of refueling equipment, that's really tricky economically. But when you bring in the 5 and you share all that stuff across those 5 reactors, it makes a big, big difference on the operational expenses. And when you have 5 reactors, again, you get that availability, which is an extremely valuable part of this product for the target customer. So each bay that you see kind of branching off of the nuclear spine contains the secondary system, so that's where the heat is exchanged with water to produce steam. And then that steam gets shipped over to the kind of 2 buildings on the right side, which is where the electrical generation happens. And the operators would be in that building on the right as well. And one of the things to highlight on this is that yellow section, that is what the NRC is looking at. So when you see this building and it looks kind of like a friendly looking, barn, that is non-nuclear. So you can build that in a straightforward way. The yellow portion is that concrete brutalist spine that's kind of coming out of the building, which is just, slap these major thick concrete nuclear grade components together. So really thought through as a team how to kind of optimize across those 2 domains. And the end result is something that really helps with economics. Because when you kind of take the nuclear part and you shrink wrap it down close to the reactors, you're left with a design that is just better from a cost perspective for the entire civil structure. And if you look at the right, that's a traditional PWR, and on a per megawatt basis, there's a lot more complex stuff that has to be done. On the left, you see our reactor vault system, a core part of that concrete spine. And that's a big part of what makes these economics more favorable. Okay, so is this a microreactor or is this an SMR? This is neither. So a microreactor is usually 1 to 5 megawatts. The cost of the electricity it produces is somewhere between 20 or 40 cents per kilowatt hour. which is pretty expensive, but that's okay, because the target market for them is remote diesel. But the thing is, you're never going to power a 1 gigawatt data center with 1,000 1 megawatt individual reactors. We don't think that makes sense. SMRs are kind of like scaled down large plants. And the issue we often see is that the reactor might be modular, but the plant isn't really. And there is one recent example of a really large plant that was attempted to be fully modular, but it wasn't done in a vertically integrated way, which had a lot of communication breakdown and challenges. So the net result is some of these designs, they have more concrete per megawatt than any other reactor design. So today we're introducing what we think is a new category, which is an XMR. This is an extra modular reactor, which is where not just the reactor is modular, but the whole plant is made in the factory in a modular way and shipped on site for rapid assembly. So this is Aalo's XMR, the Aalo Pod. It's fully modular, reactor and plant, made here in the factory, shipped in modules. It's the ideal product to power the AI revolution and rapidly deploy around the world thereafter. But there's more to the story. And so now I'd like to pass it over to Yasir Arafat, our co-founder and CTO. And so Yasir, let's dive into what makes the pod hum.
Hello. How are we doing tonight? Welcome, everyone, to our factory launch event. We are super thrilled to have you all come here and join us in this important milestone for the company. So today is not just a pivotal moment for just Aalo, it's also a pivotal moment for the great state of Texas and the overall United States nuclear leadership. So thank you all for joining tonight. Before I get started about the pod, let me just say what an amazing product reveal that was. Wasn't it amazing? I just want to give a big shout out to the fantastic team that have brought this product to life. So let me give a round of applause to the team. So as Matt kind of covered, we designed the pod purpose-built for data centers. And as Matt kind of covered this before, we have 5 reactors connected to a single turbine. And it's an amazing system, fully confined power plant, self-contained, and it blends beautifully with its surrounding. Next, I want to take you deeper into the heart of that pod, what lies within. And if you take away all of those shells, you'll basically see an industrial facility, and you'll notice there's something we're truly proud of. And that's our Aalo-1 reactor. It is the heart and soul of that pod. So let's dive deeper. What makes the Aalo-1 reactor so special? Well, first, it has an insane energy density, right? This thing is only about 19 feet tall. Basically, if you take a regular pickup truck and tilt it vertically upwards, that's how tall this thing is. But it can power 10,000 homes for 3 to 4 years without needing to refuel. That is incredible energy density. So because it's small, we can actually build it in a manufacturing facility and put it in the back of a truck and send it to wherever power is needed, whether it be a community or an industrial setting or a data center. Next, when we asked our team to design this reactor, one of the things they wanted to do was, hey, let's make sure safety of this system is built into the physics of the reactor. So you don't need to rely on humans or control systems to ensure safe operation. The physics will handle its safety, so it's worry-free. And one of the strategies the team has used is selecting materials that have very, very high melting temperature, right? Everything's made out of high-grade stainless steel. Even our fuel, its melting point is 5,000 degrees Fahrenheit, right? So this thing can operate very hot and still have a lot of margin when things can start getting affected. Super important. And all of this safety is important because when you build a safe reactor that is passively safe, you can then bring what is called EPZ, Emergency Planning Zone, very close to the reactor. And that allows the overall pod to be co-located to customers. This is something larger reactors that are pressurized cannot achieve. So we've got a great design, safety is awesome, but we also wanted to make sure it's economically manufacturable. And one of the first things we have done is we did not select a coolant to take the heat away that makes the overall system pressurized. If you look at current pressurized water reactor, they use water to cool down the reactor. So when you try to heat it up, it tends to boil. You don't want that, so you pressurize the system. But when you pressurize something, you need very thick walled vessels. And the only way to make those vessels is by forging. And forging is super expensive, takes a very long time, and there's few places in the world that can make those. So we said, no, we don't want any forging whatsoever. We want to use a fluid that allows us to operate at high temperature without pressurizing the system. So we can use thin-walled vessels. So we selected a fluid that is an alkali metal, meaning liquid metal coolant. What that allows us is to have not a pressurized system. Instead of using a forged vessel, we can actually have thin plates rolled up, welded together, and we can make our vessels. Lastly, which I think is the most important one, we do not use any exotic fuel in our reactor. Our team has figured out how to use commercially available UO2 fuel to power these advanced reactors, right? That is extremely important. We don't use HALEU, which is like 20% enriched, which some of our peers in the industry uses. That material is not available in the country at large quantities. It will take many, many years before we get there and bring the cost down. We use commercially available uranium dioxide fuel that we can literally purchase from existing suppliers. In fact, a lot of those suppliers are actually here in the audience today. Urenco, GE, Framatome, we're working with them to actually purchase the first batch of fuel for our first nuclear reactor very soon. And that is something very unique to Aalo. So when we want to scale up from one reactor to many reactors, getting fuel for these reactors will not be a challenge. So extremely important. Now, all of these things that I just mentioned, these are extremely important attributes of the Aalo-1 reactor, but there's something more that's what makes this reactor very special. When we first started designing the Aalo-1, we designed it very differently from day one. We designed it what is called design for manufacturability and assembly. That means every component that you see in this system is optimized to be built quickly and efficiently in a factory setting. From the core, fuel pins, the reflector, to the heat exchangers, the piping, the systems that holds everything together, and the vessel. They're all designed to be built quickly and efficiently in a factory setting, and that's why we call it extra modular reactor, XMR. So we're not really constructing a huge reactor in a construction site anymore. This is not our grandfather's reactor. This reactor is something that we're manufacturing in a factory. We're not building it on site, we're manufacturing a product. So enough of that. We've shown you a lot of animations. Now it's time to actually see it for yourself. Ladies and gentlemen, I am thrilled to present to you for the first time ever our full-scale Aalo-1 reactor prototype.
this, folks. It is the Aalo-1 reactor. Isn't she beautiful? Let's go.
We deliberately took the core out so it doesn't go critical. All right, let's take a moment to appreciate this. What you're looking at right now is a full-scale Aalo-1 reactor. This is the actual prototype. It is not a scaled-down version. It is at full scale, right? And it is fully functional. We're intending to take that machine, stick it into the vessel, and ship it into a plot of land in Texas, load sodium, and test the overall system, how it operates in the next few months. So we're really excited about that. Now, from down in this angle, it looks kind of big, but I promise you, if you drive a Tesla Cybertruck in here and you lift it up vertically and put it next to it, it's going to be exactly the same height, except our reactor looks prettier. All right, so building one prototype is great. I mean, many have done that, right? Other companies in our industry have built a prototype or two and showed some awesome concepts. Don't get me wrong, these are important milestones, but these are just the very first steps. You know, building a single reactor alone doesn't solve our overall problem. The world needs not just one reactor, but hundreds or thousands of reactors to truly make a difference. So we need to find a way how to build lots of these and very fast. We don't have time. The question is, how do we go from one to many? Well, I just want to share with you a personal anecdote. You know, I've been in the nuclear industry for about 15 years. And about a decade ago, I was working on some of the very advanced reactors in that era in Westinghouse. And these are just incredible plants, right? Really large systems. And what we have learned during that time is, like, these are very, very complex construction projects. Every single component, every single vessel, every piping, every electrical system are very unique and bespoke. So the construction project became very, very complex. Even if you try to build these systems in modules and bring them on site, it still takes many, many years to put them together, right? So back in my head, I was thinking like, well, you know, is there a better way to do this? There has to be a better way, right? Why can't we just take this nuclear technology and build them like airplanes or cars, which are all made in factories, for example? And people were like, no, I mean, that's very hard. It's complicated. Nuclear, you can't do that. Look at this system. It's massive. It's complex. You can't build it in a factory. But that very thought kept on lingering in the back of my head. And it lasted in there for about 10 years. So fast forward in time, I never let go of that dream, right? I wanted to make sure that what if we can actually achieve that? Now, these reactors kind of looks nice and tidy when it's all done. But during the construction project, this is what it looks like. It's one of the largest mega projects mankind have embarked on. Very complex. It takes nearly 10 years, at least, minimum, to build one of these from construction, and by the time you complete it, thousands of workers, right? So it's a very, very long time. It's basically half a generation. We simply can't afford that kind of timeline to tackle some of the big challenges of humanity, like energy security or climate change or powering data centers to power the next AI intelligence age. We can't do that. We can't wait for that long. The world needs clean energy now, not a decade from now. So when we started Aalo, we said, hey, nuclear has a lot of problems, but what if we could focus on just one problem? If we could just wrap our minds around one thesis, what would that be? What problem would we want to solve? And Matt already covered this, that is speed. Speed is everything, right? We realized that to deploy these reactors in 10x the speed as we do conventional reactors, we have to think about a different way fundamentally how to go about this. So, for example, if you want a gigawatt reactor, you can go on the left-hand side, the conventional way, build the construction site, Wait 10 years to get your first electron. That's method one, no problem. But if you wanted to speed that up by 10x, you take a 1,000 megawatt reactor, shrink it down to about 10 megawatt, about this size, and print them in a factory, right? So if you build hundreds of these or 20 Aalo Pods in a factory setting, you get the same 1 gigawatt every single year. Not every 10 years, but every single year. And that's the kind of speed that we're talking about here. If we can achieve that kind of deployment, I think we can change everything. But that has never been tried before, right? So why build it in a factory? This is a complex machine. Can we actually do it fast? Well, there are other complex machines that we build in factories. For example, a car, right? Here in Austin, Giga, Texas, from their assembly line, every 13 seconds, a Model S rolls out. Every 13 seconds. That is mass manufacturing in action. That is what we can achieve in a factory setting with a set of dedicated people, dedicated equipment, so rinsing and repeating the same thing over and over again so you can do it very fast. Well, one might argue, a car is kind of simple. Not really, actually. Cars usually have more numbers of parts than our reactor. But nuclear is kind of complex if you think about it. You know, this reactor is a little bit larger than a car. What about a plane, right? If you look at what Boeing does, they make their planes in a factory. And they can make a full-blown, from start to finish, an entire plane in less than 10 days. And we think our Aalo Pod is similar kind of complexity, between a car and a plane. And I think we can get there. So if you want a lot of cars, you build a car factory. If you want a lot of planes, you build in a hangar to build a lot of airplanes. But what about nuclear reactors? No one has actually achieved it. Not at this scale. What if we wanted to manufacture this very reactor that you see behind me in a factory setting? So let's take a look. This is a building that is about the same size where you're sitting in right now. And we decided, hey, we built a nice prototype. What if we wanted to build a factory out of this space? What would that look like? The first thing we would do is take a look at the reactor design and look at the overall layout and figure out what kind of equipment, what kind of optimal spacing that we would need, what kind of people and automation. And the first step would be to bring in the raw materials coming into the factory, where we can have a dedicated team pick up the bars, the pipes, the plates. Those are raw materials needed to build an actual reactor or a plant. And we would have dedicated places to store these components. And then, take one of those plates, you can roll it up into big rings. You can connect 2 rings using a semi-automated subarc welder, and you can make your reactor vessel. But it's not just about the vessel. You need to figure out what goes inside. So we will need a lot of fabrication equipment. For example, this water jet, we can actually cut large pieces of steel at least 6 inches deep with just using water pressure at very high precision. We will also have other components that will have to be CNC milled by standard equipment that we can just buy off the shelf. There's no bespokeness in here. Like a CNC mill, we can also use a lot of the existing equipment like lathe to build some of our core components and bottom nozzles of fuel assemblies. We also have a lot of parts and pieces that have to be using bent plates. So a press brake can be used to bend metal with extreme force. So all of these are common equipment. We would take all of those fabricated parts, put them into a different area where we start pulling them together, whether it be welding or repetitive processes or being able to make the core components. We can also build the larger parts and pieces too in a factory, like these steel composite modules. With a combination of humans and robots, we can optimize the overall production in the welding area and start connecting some of the larger sub-assemblies of a reactor, like the primary coolant system. We also need to hold all of these things inside the reactor so we can also combine and assemble some of these components. To load horizontally, we have designed a custom jig that will load all of these heavy equipment inside the reactor without damaging it. And by doing so, we can complete the sub-assemblies, take all the parts and pieces, load it up on a truck, and then drive out of the factory. And we can repeat this process over and over and over again to make many of these. We just showed you the reactor, but it's not just the reactor. We can build all of the various modules of the pod in a factory setting. So what we have learned everything tonight, if we summarize this, the first step is factory made. We're no longer doing stick build approach anymore. We're building everything in a factory. Second, most of those made components have to be transportable in standard transportation modules. So we're not doing anything bespoke. So we can bring power to the people, not for them to wait many years to get that power. And lastly, which Matt has covered earlier, is when we get to site, we want to make sure that there's very little to do. So we're not doing a traditional on-site construction anymore. We're doing a rapid plug-and-play installation type of an activity where we bring in the modules we've built in factories, set them down, and build the various bays of a pod and be able to achieve this very, very quickly. Now, initially, to build a pod, it might take us a day or two, I'm saying a day, but a year or two. That would be very nice, wasn't it? But ultimately, our plan is to achieve less than 90 days to build an entire pod of 50 megawatts electric. Right? And if we can achieve that, we can be as fast as some of the fastest moving data center companies who are building hundreds of megawatt data centers in a matter of months. And if we can work together in that same speed, we can make this happen in reality. So I've talked a lot about factory, and because the factory manufacturing is such an important part of our thesis, we didn't just work on this reactor design as a product. We worked on two products, right? First, the Aalo Pod, which Matt has revealed, and the engine that powers the pod. But we've also been working on the factory as our second product. We have revealed to you the first one so far. Now I think it's time to reveal the second product for the evening. Before we do that, I want to call upon Matt to come back on the stage. Let's do it together. All right. Now, I know in Aalo, we pride ourselves to go 10 times faster than our peers. And so we moved in this facility about 6 months ago. It was an empty shell. And we've been pretty busy.
So there's actually these two products. There's the pod and the factory that builds it. So we just revealed the Aalo Pod and the engine that drives it. And now it's time to reveal our second product.
Okay. You all ready? Let's go.
Let's roll the tape.
All right, don't clap just yet. Are you all ready for the second reveal?
All right, let's do this.
The Aalo Factory.
All right. So yes, what you have behind us here is the Aalo Factory. We're very excited to give you all tours very soon. However, before we do that, we have a few external voices that we're going to hear from. So essentially, right now we're going to bring on a few potential customers and partners and industry experts and dive a bit deeper into the nature of what we're up to here. So to kick things off here, I'd like to introduce Mark Nelson. Mark is the founder and managing director of the Radiant Energy Group, not to be confused with the Radiant Nuclear Reactor Company, different company. But Mark is a well-known figure in the nuclear industry. His work has been covered in the New York Times, the Wall Street Journal, and leading European papers. So ladies and gentlemen, please welcome Mark to the stage.
God, this man.
I will admit that they didn't tell me that I was going to come up and talk with that in the background. I feel a little bit like the monkeys in 2001, A Space Odyssey. So I hope to get a multi-million-year leap in cognition from standing in the presence of your monolith. I have to go back in history to go forward. A long time ago, back in 2021, before we discovered AI, apparently, there was no need for industrial electricity in America. Some of the largest and richest countries and, companies in this country, so for example, sort of the $1, $2, $3 trillion market cap companies, had been treating energy, especially industrial electricity, as just a silly marketing game. And the way it sort of went like this. So a bunch of our most innovative, powerful, and influential companies, they needed ultra-steady electricity in large amounts from small things. So what they did was the exact opposite of that in terms of what they announced to the world. So what they would do is they would order faraway electricity that went on and off, and then they would put their data center in wherever they needed it, which was typically on the grid, by the people that it was supposed to serve near the coal, gas, and nuclear plants that actually provide electricity like that. So this was extremely good from a marketing perspective, but you effectively had a situation where we had multi-trillion-dollar stars of the American economy going to war against the, say, $5, $10, $20 billion laggards that do things like make steel, the other construction materials, produce energy, stuff like that. So this went really well from the mid-2010s all the way up until an extremely long time ago, about what, 24 months ago, when suddenly our most innovative companies discovered that they were industrial electricity. And I know I've lowered the tone a little bit, but I had to get this just a bit off my chest because we saw the projections of AI, and is it going to be a little more? Is it going to be a little less? Well, maybe those projections are pessimistic if we have the energy to power it, but we have a significant problem in that what American electricity has been doing in this decade, about 24, not decade, century, millennium, so since 2020, since 2000, American electricity has stayed right about flat at 4,000 terawatt hours. So, sounds like a big number, but what that means is it's gone from about 14 megawatt hours per American down to about 12 megawatt hours per American. So what's happened in China, you know, a poor but developing country with a lot of ambition, they started the millennium at about 1 megawatt hour per person, and they'll end this year somewhere north of 7. And trust me, that wasn't because, you know, they haven't grown in population, so that helps a little. But what we've seen is a 7x electricity jump in China. And then in the USA, we've gone from 14 to 12 as our electricity production has stayed flat or slightly declined. And what happened only a few short business quarters ago is that the companies that had been advertising themselves as using energy one way, but had been doing it that way, suddenly are advertising themselves as needing exactly the sort of energy that should come from this. So even if people say, oh, AI is a little overblown, we already literally needed energy at the scale and of the quality that we just heard about in your presentations. We need it whether or not there's going to be more AI or not, and that leads a question to us, to your solution that we have in front of us. Now, I'm an outside voice, and these gentlemen took a big, lovely risk in having me up here. I think we're going to be pursuing several different options, but let me say this. Of the fast and innovative options that I've seen out there, there's been just one that I personally have decided to back. I'm not saying I'm the world's greatest investor, but I do talk to a lot of nuclear companies. I've met a lot of nuclear founders. I'm a decade into nuclear. That makes me practically an old-timer compared to some of you in this room, and just a baby compared to others. I wanted to mention why it was so meaningful to join up as an advisor and an early investor in Aalo. There's a lot of claims people make about their reactors. There's a lot of work left to be done. We've seen reactors start this big, get a bunch of funding, and then much later they're actually this big, and the design changes keep rolling on and on and on. I was less interested in what Matt and Yasir were wanting to pitch on the technology. Yasir's the expert on that. I'm too far away from that now. What I needed to see was somebody, a founding team, combining two very important traits, each often found separately, but not together. And that is absolute urgency and humility at the same time. A weird thing to say, but it's very hard to find those two things together in nuclear founders. A need to go 7 days a week. Sorry, everybody who works for them, but I hope you enjoy the mission along the way. But also to understand what you do and don't know, and to have respect for the technology, respect for the people and the systems and the institutions that have come before. Now, I may think there's a little more hope for some of the large reactors, but I'll be damned if I'm going to miss this show and not see this journey to the end. 2 days ago, I was at the University of Chicago at the Chicago Energy Conference put on by the students of University of Chicago and Northwestern. And a very strange question came up on my panel, which is, what if a bunch of people hate AI and they want to burn down the data centers? And I'm thinking, where is this question going? And then people hate AI so much that they hate the nuclear plants near AI. What's in it for the public if the public feels alienated from AI? I love the optimism we're hearing here in Texas, but I'm telling you, a lot of places are feeling left out or don't know whether there's something in it for them in this video, in this product behind me. This is a pretty cheeky question to come in a city where 110% of Chicago's 8 million people, like 110% of our electricity right then was coming from nuclear, right then. So to say, what's in it for us? Well, if this works, if this journey continues, then the many things that were not being built right, powered right, advanced correctly in this country, but were being aggressively pursued in China before anyone was talking about hyperbolic growth of AI. Those are the goals that are just the starting stakes for what we're going to get right when we see Aalo succeed. So it means the world that I'm here with you guys. Thank you again for having a cowboy like me up on the stage, and I cannot wait to tour the factory along with the rest of you tonight. Thanks.
All right, thank you, Mark. So this next section, we're going to talk about the Aalo-X project very, very briefly. This is our experimental power plant we're building at Idaho National Lab, and we are currently on track to start construction on this plant in 12 months. And so, yeah. So it's a very historic site. This is where some of the first reactors that ever powered a small city or even a light bulb were built. And we have this plot of land right there that's been tentatively allocated by DOE, the Aalo-X site. And so the person we're hearing from next is the person in charge of licensing and authorizing this plant. And that person is Bob Boston. He's the head of the Department of Energy, Idaho, and he's got a few words to say.
My name is Robert Boston. I'm the manager of the Department of Energy, Idaho Operations Office, or DOE-ID. Today we're at a critical moment for nuclear energy. Right now, new nuclear technologies have strong support from the President, Congress, and the public, but we can't take the support for granted. It's time to deliver results. We need to demonstrate that we can deliver safe and efficient nuclear energy to meet the needs of the United States. My office and the Idaho National Laboratory are directly aligned with Secretary Wright's priorities in unleashing a golden era of American energy dominance through advancing energy sources, unleashing American energy innovation, unleashing commercial nuclear power in the United States, streamlining permitting, and identifying undue regulatory burdens on American energy. We need to build nuclear reactors and show that they are more than just good ideas on paper. It's time to bring these concepts to life. The Department of Energy and Congress are backing nuclear energy development by providing land, funding, materials, data, and laboratory capabilities. This support is crucial for the success of the United States. Several years ago, a passionate nuclear engineer walked into my office with the idea to design and build a new reactor using commercial off-the-shelf technologies. He wanted to show the United States that we could still build reactors. That reactor is now the MARVEL project, currently in final design at the Idaho National Laboratory. The nuclear engineer's name was Yasir Arafat. Yasir's idea has led directly to Aalo-X. If we don't achieve some wins and deploy new reactors soon, we risk losing the support of the nation. The time is now to deliver on nuclear. The DOE Idaho Operations Office is committed to help nuclear energy move faster and be more adaptable to new technology. The Department of Energy, the Idaho National Laboratory, and Aalo are working together to help develop and deploy Aalo-X project at the Idaho National Laboratory as an experimental development reactor. Aalo has completed the safety design strategy and is well underway in working through the DOE authorization process. We're excited to partner with Aalo team and the Aalo-X project. Their dedication, innovation, and expertise are helping to drive significant progress in the nuclear energy sector. Together, we need to make microreactor deployment a reality.
All right. The National Lab. What an incredible piece of our national ability to deploy. So it's really great to hear from Bob Boston. Hello, everyone. I'm John Guidros. I am the Senior Vice President of Commercialization here at Aalo Atomics, and I'm very thrilled to have with me 4 very important leaders and partners to us in this journey to achieve commercial liftoff for advanced nuclear. Matt, Yasir, Mark have done a great job of laying out for you the urgency around the market that's pulling us in our direction, that we're headed in behind you, all the things you've heard. And I gotta say, I am really appreciating working at a place that listens to the market first. We're not just a technology-forward company. We're also very customer-obsessed and market-obsessed. So it's a pleasure to be in the role that I'm in. So without further ado, I think this esteemed panel of 4 is going to really have an interesting discussion, and I'll do a quick introduction of each of you, and then maybe we'll get it going. So immediately to my left is Arnaud Paquet, who leads clean energy procurement for Crusoe. If you don't know Crusoe, they're the guys deploying the AI infrastructure and data centers at lightning speed that you heard mentioned moments ago. So we look forward to hearing from Crusoe. Thank you, Arnaud, for being here. Continuing with the Department of Energy, Idaho National Lab, we have Brad Tomer, who is the director for the National Reactor Innovation Center at INL, leading efforts to partner with industry and accelerate demonstration and deployment of advanced nuclear technology. Continuing down the deployment curve, we have Dr. Joe Elab from Texas A&M, representing Vice Chancellor of Texas A&M, representing a groundbreaking initiative to deploy a gigawatt or more of advanced nuclear at the RELLIS campus, just, what, an hour or so away from here. And finally, bringing us home with a lot of energy strategy and knowledge in his background, we have founder and CEO of Veriten, Mr. Maynard Holt. Also the co-host or host of Close of Business Tuesday podcast, if you've heard of it. So let's get going. Arnaud, we'd love to hear from you. I mean, McKinsey, many others have highlighted this multi-billion-dollar opportunity to deploy AI infrastructure, and we hear about power being a constraint there. What are your thoughts on this?
Yeah, thanks for having me, John. So when we think about the bottleneck is both a bottleneck of power generation and transmission capacity, right? And so what used to be a couple of months, and Matt mentioned that on the slide, what used to be a couple of months to get your load approved to connect the data center to the grid is now increasing to years. And it's becoming really hard to plan these multi-billion investment in large-scale AI infrastructure. And so our thesis at Crusoe has been to actually build these large loads where the energy is. And so that's why historically data centers have been traditionally built in Virginia, and now we're building this large-scale AI infrastructure in places like Abilene, if some of you have heard about our 1.2 gigawatt data center in Abilene. And so that's kind of like the mindset we have at Crusoe, is going where probably no one else is going, and leveraging existing energy at these sites. And so when you think about where the industry is going, I think these hyperscalers and the industry is going to always be looking for more power. And so as we build these sites, there will always be a demand for additional capacity. And that's why, the Aalo solution is kind of like the perfect fit, because as Matt and Yasir have mentioned, you guys have a technology that is super flexible in terms of location, in terms of scalability, and requires little to zero water. And so as we build these data center campuses across Texas and the US, the ability to then add some firm, clean capacity to our existing power supply mix and what we call internally our power orchestration strategy brings tremendous value. And so that's kind of like the solution we're trying to solve in the medium term with you guys. In the long term, and this was already also mentioned, when you think about the large-scale reactors, for example, the AP1000, if you collocate a data center with an AP1000, the problem you're going to face when this reactor has to refuel and going offline is you're basically losing a gigawatt of power. And so then you need to go to utility and ask for a gigawatt of power from the grid, and utilities rightfully are going to be very upset, because you're basically requiring another gigawatt from the grid. And so the ability to rely on more modularized nuclear capacity, and you can stack up these modules and these pods, these XMRs, in a way that then you can appropriately plan the refueling so that you can still keep your GPUs running, and that's a wonderful ability. So yeah, we're really excited to look what's going to happen in the next years, and I think there's amazing synergies between Aalo and data centers.
Yeah, thank you so much, and thanks for really representing the market around this. It's incredible to collaborate with you guys. Dr. Elab, could you give us a little bit of an overview of what's going on with Texas A&M RELLIS campus and how you guys are thinking about the proving ground?
Yeah, so we're really excited because you're going to come to the RELLIS campus, so that's our biggest excitement. But, with our campus, which is in Bryan, Texas, about an hour away from here, it's an applied research campus. And one of the thoughts that we have had over the last couple of years in the energy space is, can we have, as an agency of the state, how do we serve the state in the energy demand? And what would it look like if we invited energy companies on our land and help them de-risk and accelerate their path forward? And really, as a partner, really a plug-and-play site where you would come, we can provide infrastructure, we can partner with you, with the local community, the state, and the NRC in this case. And so last year we started a process where we issued an RFI and then an RFP. Obviously, Aalo went through a very rigorous process, and a couple months ago we announced 4 SMR companies that will be siting at the RELLIS campus. Aalo is one of them. We're very excited about this and being a part of your journey. I think today just adds to that excitement here. The speed at which you are delivering, you are definitely delivering on your promises. We're very excited. I'm very excited. I can't wait till Many of these are on our campus very soon. And so we're very excited to help be a partner with you. And it's great because you're here, it's about an hour away. We'll have these reactors sited and producing electricity soon. And so we're very excited. I can keep talking, but I'll let other people talk. But I can't tell you how excited we are to partner with you.
Thank you so much, and thanks for being here just an hour away. Yeah, let's hear it. Brad, we've heard a bit about INL already, but we'd love to hear from you and how you're thinking about really partnering with companies like Aalo to achieve commercialization and what the lab can do.
Yeah, I'll start with a little bit of history of INL. In 1949, INL has its roots in the National Reactor Test Station. And the goal in 1949 was to test 10 reactors, build and test 10 reactors. Since then, we have built and tested 52 reactors. So we have experience at building and testing reactors. You saw in the photo where you're going to do your test reactor at the Materials Fuels Complex at the Idaho National Lab, all the facilities and everything that is available to a reactor developer such as yourself. And, you know, since we did those 52 reactors, we are really now the nation's national laboratory for nuclear energy research. And in 2019, we formed the National Reactor Innovation Center, which I am now the director. And our remit, our mission, was to partner with industry to bridge that gap between R&D and commercial deployment. And we're doing that with several partners, including Aalo. And it's very exciting because what we're actually doing is bringing the full force of the National Lab Complex, all that expertise, infrastructure, and everything together with all this innovation and speed that companies like Aalo are bringing together. And that really sets the stage for making something special happen. And we're really excited about that. And I brought a little section of a memo with me today that came from Secretary Wright. It was dated February 5th, and it was to all the department heads of the Department of Energy. And its title is Unleashing the Golden Era of American Energy Dominance. And it sets out a bold and ambitious agenda to expand energy and reduce cost. And a portion of that memo had a section called Unleash American Energy Innovation. And in that paragraph, it talks about the national labs and everything it has to offer. But it also says that we're going to prioritize, the department's going to prioritize the commercialization of affordable and abundant energy and enable the rapid deployment and export of next generation nuclear technology. And so I think the partnership with Aalo and the National Reactor Innovation Center and INL hits that right on spot. So
thank you for that. Thank you for bringing that memo out. I don't think we have seen a moment for nuclear quite like this in a generation, at least. So thank you for that. And Maynard, you bring just such an interesting perspective. Veriten, before that, co-founder of Tudor, Pickering and Holt. Before that, managing director at Goldman over Energy. I'm curious from your perch, what are you seeing around the theme of nuclear? What are you hearing from energy and industrial companies about what they need to see from this sector?
Sure. Well, first of all, let me just say thanks for being here, and Matt and Yasir, John. This is super impressive. I think probably the place I'd start is it's amazing how the attitudes around nuclear have changed. You mentioned Close of Business Tuesday. This has been a 1-hour conversation every week for 5 years. If you go back, 4.5 years ago or somewhere in there, we were closing Indian Point. So to be there and to be here, it's so dramatic. I think what's really interesting as you look at all the potential energy solutions and power solutions that we have, it's just pretty clear to engineering-minded business people that nuclear is going to play a big role, right? We went through a period here where we were talking about a lot of technologies, talking about a lot of things that could happen. And my experience with energy professionals and investors is, regardless of what flavor they were currently in, the one thing we know about nuclear is it works. It works. And a lot of the other things we were talking about, you know, we don't know if they will work, right? So I think when we think about the energy macro, I think there's a couple of points that are worth hitting. One is just growing energy demand, period. Whether it's an AI-driven data center or it's just, you know, Vietnam needing more power. I mean, I'm just picking kind of both ends of the spectrum there, but we need a lot more energy, we need a lot more power. So there's just a big growth wave that's underway here. I think the second thing that's really interesting is when you look at it and you think about fuels or ways to generate energy and power that will capture market share, natural gas and nuclear stick out, right? We have plentiful natural gas. It's all over the world. It doesn't, you know, nothing's perfect. Everything comes with trade-offs, but natural gas sticks out and nuclear sticks out. I think the third thing that's really interesting that people don't really talk about so much is just, you know, right now we're all in tariff mania. But tariff mania is really just the latest version of a competition amongst nations for industry. And that's been going on, you know, forever. And the place that it has been really showing up, and I think this is Secretary Wright's comment, it's been showing up in the cost of your power. That has been one of the key features to where you decide to put a plant. Whether it's a plant or a data center, you pick it. And, you know, New York State has 40 cents a kilowatt hour power. California has 40 cents a kilowatt hour power. Europe is deindustrializing because of the cost of their power. Texas, all things considered, is the great place to put your business, and one of the reasons is power. So power is sort of the new battlefield, right? And we, of course, desire as a society to have lower impact power. And so if things have to work and they have to be reliable and they have to be have reasonable cost, if you start solving for those things, I think nuclear jumps out. What the last point I'd make is, and this is where Aalo is starting to stick out, is we went from a world where we were closing Indian Point to a world where there's a lot of energy noise, or nuclear noise, right? Startups, other companies, new technologies. Our guy, Brett, yesterday we had a big fighting with each other about thorium and breeder reactors. He knows what he's talking about, I don't. But the point is, I think what nuclear now needs is for the leading companies to separate out from the pack. And I think today has a lot to do with that. It's kind of one of those moments, because if you're on the outside looking in and you're thinking, I want to get involved in nuclear, there's a lot of names. And so when the leaders start to separate, I think that's when you're really going to get kind of the pile-on effect, and then they're going to get more momentum, and then those companies will really have a good chance to make all this stuff, you know, happen in scale.
Yeah, that escape velocity that's required. That's really interesting. And we do think about it as this ecosystem. I mean, Yasir called out a few of the fuel side of the ecosystem. You'll see some more in the factory when you take your tours. And we have to get there together. And it's going to take this demand side and the partnership with the lab, university, customers. I was at Microsoft. We used to talk about the watt-bit spread, right? The value of the electron is not the same as the value of the compute. And the urgency around that compute. Arnaud, I want to go back to you. You were talking a bit about the infrastructure build out. How do you think about, I mean, we heard about natural gas turbines, there's clean, firm power. Maybe talk a little bit about what that really means and what your end users want, what's needed for the infrastructure, how that compares to what's available today.
Yeah, sure. So I think, I mean, Crusoe has been, you know, pretty much technology agnostic. So we're looking at all the sources of energy, whether it's gas, nuclear, renewable storage, geothermal. And so just a quick, if we were to take a step back, I think one fallacy that has, you know, remain in the industry is this comparison based on the LCOE, right? And everything was compared just based on the LCOE. And so
LCOE, levelized cost of energy.
Cost of electricity. And so, of course, when you take just the LCOE and you take a snapshot, then probably, yeah, wind and solar are going to be the cheapest source of energy. But, you know, to go back to AI infrastructure, we require a firm supply of power. I mean, whenever the GPUs and, you know, are running, and whenever the end user of the data center we build is actually, you know, training the model or, you know, running inferences, we need energy. And so that, you know, firm supply of power can only be met by firm sources of energy, which are, you know, gas and nuclear and maybe hydro. And so I think, you know, and this is really important. So I think the willingness to pay from the AI industry, if we're to talk about nuclear, I think the right comparison is actually not the LCOE of wind and solar and the LCOE of nuclear. It's actually the LCOE of, if you care about the clean energy environmental attribute, is what would be the LCOE if you have to overbuild renewables with storage? And I think that's where we're at. I think we demand like firm supply, and whenever the GPU loads are running, I think we need energy. So I think that's why we're very excited about the renaissance of nuclear energy, is because if you demand firm clean energy, you don't have many options. And we believe nuclear can really be competitive with the mass manufacturing approach, and that's where we stand right now.
Thank you for that. I know everyone's been in their seats for a while, but maybe we close it out with a quick lightning round, a sentence or two from each of you. We'll start with Maynard on the end. What sort of excites you about this moment?
Well, I'll do a tired analogy, but maybe it's the case. When you think about big nuclear, maybe the analogy is to, you know, that's like drilling in 6,000 feet of water, right? And so we had those eras in oil and gas, and we had it in nuclear. When you think about what this is, maybe the analogy is shale, right? Because the shale analogy was, hey, we know it works. We've just got to get the cost down. And we're just going to pound away on that cost until we get it to work. And I think that's Secretary Wright's background, which is multifaceted, very technology driven, but he was a shale entrepreneur. And I think his passion for these types of situations is strong, and I think it has a little bit to do of thinking, I'm going to put a dollar to work, and I'm going to try to do it in a place where I know it's there. I just got to get the cost down. Yeah. So I think that's an analogy that you know, it might be worth holding on to.
That's a great call out. I'm remembering they called it a factory-based approach to well site construction as well. So there's some analogs there. Thank you for that. Joe?
Well, you know, we're really just excited. The governor has called this a nuclear renaissance. We're excited to be a part of that, a part of your journey, and that you would come into an ecospace where we feel like we can really contribute with, we educate over 150,000 students across the state. Obviously, we have a research mission and a service mission, and we're very biased. We think we have the best engineering program in the country, even better than UT sometimes.
There it is.
But, sorry.
But I knew it had to happen once.
You know, but you know, we're really excited to be a part of also the development of the new next talent, right? We have to develop the next talent. We have some faculty here from our nuclear engineering department. They're very excited about developing the next talent of students that would then work for Aalo and other SMR companies, and we're excited to be a part of that process. So,
and we can't accomplish this without the talent pipeline, and thank you so much for that. That is so important. Brad.
So I'm supposed to say what we're excited about?
Sure.
Okay. I forgot the question. Yeah. So yeah, we're very excited. You know, I think this partnership with Aalo really brings together the best of the national labs and a startup company. You know, national labs have a lot of tremendous expertise as evidenced by the fact that Yasir used to work at Idaho, and now he's come out here and started a new company.
Thanks for training them up.
Really what Aalo is doing is bringing that expertise from the national lab and putting it together with a startup, right? And Enric, you know, I had my program review last week, and we had hundreds of people there to talk about it, but my theme was, we're going to do this at startup speed. And so I think this whole idea of, you know, the nuclear industry has been kind of slow, if you will, to accept, to do new things. And I think this startup model is exactly what we need to get things moving. And together with with what we're doing at the National Lab is really going to be a great partnership. That's exciting.
Amazing. Thank you. I feel like we've already asked you twice, but what's exciting to you?
Very quickly, I mean, nuclear approval is at a 40-year high, I think. I mean, it's amazing, and so now it's up to the industry to deliver, and I'm excited to see what Aalo is capable of. So I think the best is yet to come, so really excited for that.
All right, well, it's not just technology built for technology's sake. The market is there, it's pulling us, we're collaborating with the ecosystem it takes to launch it. And we're very proud to have everybody here tonight to continue that trend. So thank you to the panel for joining us. Let's give them a round of applause. Thanks, guys.
Please welcome back Matt Loszak. Yeah, Yasir. All right, so we basically wrapped up. But a few final comments and notes. So first of all, thank you all so much for coming and seeing what we've been up to for the past couple months. We'd love to have you guys back in another 6 or 12 months to see what else we can do as we keep scaling rapidly. But first of all, you know, this is a big thank you, not just to the team we have at Aalo, but also all of you guys. You know, we always say it takes a village to build a reactor, and this is the village. It's us, it's you guys, it's the investors, it's the press, it's the government, it's everyone, all the partners. And so, you know, thank you so much from the bottom of our heart. We really appreciate it. Thank you.
I just want to add to what Matt just said. I think 6 months ago when we moved to this facility, I asked the team, hey guys, we need to go build this reactor. But not just that, to build a factory that would build a reactor. And they looked at me and was like, are you crazy, dude? But I believe in that team because every single people on Team Aalo, every man and woman, they're just the very best in the country. We've got a very small team, but they can achieve the capability of 10x of other teams. So we're really, really proud of the team that did all of this. Just to give you an idea, okay? If you want to guess how long it took us to put this reactor together. So the parts were made, but to pull them all together into a fully assembled reactor, the team did that in 2 weeks. 2 weeks. And that's just the beginning. So I just want to give a round of applause to our team. Where are you guys? Do this alone, right? In the middle section, you see a ton of partners and suppliers. We are not building everything. We're reliant on folks that have done excellent work and brought pumps, turbines, fuel, metals, all of these components to the market, and they're the very best out there. We can't do it alone. We need you all, and many of you guys are here in the audience. So I just want to thank all our suppliers and partners to work with us. We want your business to grow as we scale. So thank you.
And so lastly, thank you to all our investors so far. We've had around 30 investors come in the seed and Series A. So thank you so much for believing in us very early. And really, 50 years for the first check-in. Thank you so much for believing in us. It really means the world. All right, so up next we have the factory tours. So these are going to be 20-minute factory tours, in groups of 20. And so please don't take photos back there. So there's a lot of confidential stuff, but for your eyes only, you can check it out. We're gonna have some fun back there, be safe, watch your step. It is a real factory environment. And for those waiting out here as well, if there's a longer line, we're going to have the basketball game. I hear there's a big basketball game tonight, so that'll be playing up on the screens. And if you're a Series B investor who wants to chat, I'll be around here, so that's fine with me. And so to close out, we've got one last video. Oh yeah, and yeah, please take photos of this, the nuclear prototype. So, okay, close out, we've got one last video, and we'll roll that.
In business, timing is everything. The market has to be just right. The customer mindset has to be just right. The technology readiness has to be just right. And when everything is just right, amazing things can happen. Today, we stand at the dawn of a nuclear renaissance, a moment fueled by urgency, innovation, and unprecedented demand. AI and data centers are transforming energy into intelligence, and with electrical grids struggling to keep pace, energy security, job creation, and sustainability have become top priorities. And one solution stands above the rest, one that is clean, reliable, affordable, and safe: nuclear energy. Nuclear momentum is everywhere. Many companies, many technologies, many approaches, many promises. But the challenges remain enormous. Choosing the right technology, building the right product, securing the right supply of fuel, scaling production, navigating a changing regulatory environment, moving fast. Other nuclear companies have missed their chance. Some were too early, many were too slow. Most designed their products for a centralized bulk power system and not for the modern data center revolution. Not for this moment. So now it's our time, and we are built for this. We've already accomplished more in the past 2 years than others have in 10 or 20. With the right product and the right team, with extra modularity and a scalable factory, with mature technology and the right economics. The conditions are just right. The market is ready. We are ready, and we won't stop until we've changed the world.
All right, thank you.